Hi. Yeah, I went to the University of Utah and I worked with their environmental engineering department. But yeah, my housing situation at first was a little rocky. I got switched between, I think, 5 different houses within a week by this one lady that we were going to be working with in the Airbnb thing. But I finally went to the house that I was supposed to stay at, and it was rough. I was going to be staying in a little room all by myself with other people in the house in different rooms. And so my parents and I were very uncomfortable with that, and we luckily had some very awesome friends that were in Utah, and I got to stay with them instead, and it was a awesome experience. So anyway, on to my internship. So I started with Python coding. I kind of got thrown into this. I didn't really know what I was going to be doing, and at first I was doing this to fill my time before I was able to work with some machines. But anyway, I started with the TOTHS problem, which is that far left, yeah, right? I don't know. Anyway, that one. It shows the groundwater flow, because I was working with environmental engineers, and they worked a lot with water flow and that sort of stuff. And so we have it flowing from the high hydraulic head, which is the yellow, to the low hydraulic head, which is that purple over there. And then once I was done with the TOTHS problem, I moved on to the REA, which is the representative elementary area. And so this represents porosity of different rocks, which also kind of ties into the groundwater flow because the water would flow through those holes in the rocks. And so this little circle grid up here represents like pieces of gravel or like pieces of rock with like little holes where the like white things are. And so I coded all of this in Python after not knowing Python coding at all. And then we, in the code, we also took the porosity of random samples. So we took like different sizes, and I coded all of that, and I was super proud of doing that after not knowing any coding. And this was the porosity that came out. And as you can see, it's all very crazy in the beginning because you're either taking really tiny areas and they would either be like a single hole or a single rock, and so the porosity was very spread. And then once you get to the bigger areas, it kind of like levels out a bit more, and it is the representative elementary area. And this is useful because you want to know what type of sample size that you want to take once you get out to the field, because you don't want to just take a whole boulder home with you. You want to take like a little nice size to test the porosity. And in my other meantime, to break up the coding, which was sometimes very frustrating, I did a lot of 3D printing. I have taken a lot of engineering classes at my high school in Montrose, and so it was super fun to work with that again and work with their super awesome printers at the library. So I wanted to print a model of Mount Sneffels, which is that one. So that is Mount Sneffels that I actually found online. There was a little website that I was able to get the coordinates and get an area of what I wanted. And so that was really cool for the topography. And then I designed a D20 dice and like all the sided dice because I was bored and it was fun. And so it was a lot of fun. I designed those things in Autodesk Inventor, which is what I've worked with in my classes. Yeah. And then I also found some cool models on this website called Thingiverse. And so that little star thing in those top pictures is really cool because it interlocks together, and you can twist it and you can like pull it out and like drop it, and it's really cool. I did not design it, but I took advantage of their super awesome 3D printers and just printed some stuff for myself. So yeah. And I also worked with CO2 sensors. And so we wanted to test, compare the Lycor, which is a super expensive, $3,000 sensor. We wanted to compare that to like these little itty bitty, like $65 sensors. And so I got to breadboard and Arduino and all that fun stuff. I got to make these little sensors. And it was kind of difficult because for the test to work how we wanted it to work, we had to have all of the same sensors, and the ones that we ordered came in a pack of 4, and they were the same sensor, just different models. So they weren't exactly the same. And so that kind of ruined a little piece of it, but it turned out to be really cool. And we went to the lab and we shot some CO2 on it, and we compared the Lycor and the CO2 sensors. And from there, we got this data, which I also coded in Python, so little bridging between my different projects. But anyway, so this, we did a rooftop experiment, so we went onto the roof of the Union, which is like their little food court, and we went next to the Panda Express vent, which shoots out a lot of CO2, and we monitored the CO2 levels for 2 hours. And so, as you can see, there are the 5 different CO2 models. The Lycor is the purple, and it is the most accurate. And as you can see, the different models really changed the outcome, because we have the orange, which is like super high for CO2 levels. It's over in like the 1050s or 1500s. And that is very high for the CO2 that we were measuring, because the Lycor, for the most part, was down in like the 400s. And so we also are able to see the spikes where we breathed on them to make sure that they were timed correctly. And it also helped us see kind of the differences in the spikes as like the different models. Some of them were less accurate than others. And the orange, again, is a nice example of how inaccurate it is, because this Lycor spike is really small and that C spike is really large. So it was cool to see the difference of that. But yeah. And I did many different things with these people, and they were all awesome. And so I also did a chemistry lab working with groundwater and injecting CO2 into the groundwater, because this lab works with carbon sequestration. So they inject CO2 from the atmosphere into the holes in the rocks. And one of the things they wanted to know is what would happen if the CO2 got into the groundwater that's also stored in those holes. And so we spent a couple weeks injecting CO2 into different types of groundwater that we made in the lab. And we tested the pH of all of them throughout different time differences. And if we go next, this is another thing. I also worked in Microsoft Excel to create this. So I worked with a whole lot of computer stuff. And so the first point over there, you can see where it starts, where the pH levels normally are before we inject any CO2. And then that nice drop at the very beginning is when we originally inject the CO2. And the CO2 is very acidic, and so it lowers the pH level a fair amount for a lot of these. And then a lot of the stuff in the sand and like the salt in some of the groundwater kind of evens out that pH as the time goes on. And yeah. And in my free time, I got to do a lot of amazing stuff with my super awesome host family. I'm so grateful that we switched and we went with our gut, and we had an awesome time. I got to do so many things with them. I went to Lagoon, which is an amusement park there, and amusement parks are not for me. And then we went to Idaho for a weekend. It's about, I drove 3 hours from where I was staying and just stayed on the Snake River, and it was gorgeous. And here's Danny Boy, their lovely dog that I fell in love with. And yeah, and then the top is the campus. That is a skylight from the library. So the library is partially under the ground. And it is just really cool. And I also fell in love with their library. And some more pictures. I also was able to visit Park City, which, coming from Montrose, is the equivalent of coming to Telluride. So it's their ski and golf town, and it was very beautiful, this bottom picture. And then more pictures of the library, and then a picture from the geoscience building, just very, very beautiful. I also fell in love with crepes while I was there. And the library, again, beautiful. And yeah, it was just a very fun time, and I got to do some awesome things. So thank you so much to Sarah and everyone at Pinhead for sending me here and letting me have a great experience. And thank you to Kevin, Ting, and Ziti, and Adrian, who were my awesome mentors and helped me do some awesome things.